Okay, so I built this program for my CS 291 class, COVID-19 contact tracing. I mean, let's face it, COVID-19 it's taken off our daily life. And about a month ago, when I was thinking of what my final project would be, I thought, you know what, this would be a nice project to build. And even before that, I was thinking, this contact tracing is going to be very important, and now we see that it is. Um, but before I, okay, so I'm going to do two parts. This presentation is to be done in two parts. One is concept, and the other one would be the codes. Um, I'm gonna this particular video deals with the concept. Before I get to the concept, let us run this piece of code. Let us run our program. Make sure that it works. So I could do one. Now I know this is a black and white screen. People are accustomed to using their Android, their phone. They see pictures. They see this. They see that. All these different things. But building this program, it's anyone who knows computers will have an appreciation for it. I don't think that a person who wants to just enter information by an app, they would find this to be very amusing or find this to be useful. But the principles are the same, and building this using the data structures, such as an AVL tree. Um, those are some of the things. Those are the back end stuff that the user doesn't know about, but it's there. And but being able to actually build this thing is, it's pretty good. But before I think, like I said, I know it might seem unassuming. It's a black and white screen. It's a terminal. No one uses these things anymore. Why are you doing this? Well, it's a start, and we'll get into that later. Um, so enter one, and I want to search for a person, but let's say I want everyone. So it's gonna give me everybody. All right. Um, let's say I want just a single person, or just anyone that has a specific set of letters in their name. So G, these are all the names with G inside. Or you could do those are two with those characters inside. All right. Um, dresses, that. We don't need to do anything else there. Let's look at the contacts. Let's go to contacts. So I could enter a new contact, or let's do, this is the one that we want to do. We want to see all the traces. We want to see who has been in contact with who. All right, now if I enter someone's name, let's say person 14 came in contact with 20, right? Let's come back to this. I want to enter a new trace. Person 14 came in, well, let's say 13, okay, came in contact with person 16, and then person enter a new trace again. Person 13 also came in contact with person 17. Alright, now if I do show all traces, I should see the new person. So here, this is person 17. I know I probably should put the number, that way you'll actually have an appreciation. That way you could actually see the name. But Tim, this name here these names here are actually associated with those numbers that I just entered. So this is the basic idea. This is the basic program that does your contact tracing. And we look at how we can expand it later on and so on. In fact, here, let's see, person 13, that's this person here, right? Came into contact with 16 and 17. I think it was 16. What did I enter? 16 and 17? Yes. 16 and 17. Okay. So our program works. Let's exit and then exit the program. Alright, let's get down to this. Alright, so now we see that the program works. I want to go into some concept in terms of building such a program. I mean, like I said, this program is a prototype. It has unlimited potential, and whether you do it in C++, whether you do it on an SQL server system, and that's the thing, I could build this on an SQL server system, or I could build it on MySQL, I could build it on Android, I could build it on iOS, I could build it on any of those applications, but this particular program is built in C++. Um, one of the things is because of the project for the class, but outside of that, the tools that they use in Android and the data structures that they use in Android, linked list, binary tree search, AVL tree, which is a binary tree, um, but those things, all those things, you have to build it from scratch, and the ability to actually do that with this C++ program, that's what I thought was very interesting. All right, so it's just a prototype and it has unlimited potential. Not that you have to build it with this, but the concept, not that you have to build on this particular program, but the concept itself can be expanded. I think that's what I mean when I say it has unlimited potential. The concept has unlimited potential. All right. Right now, it's the number 2 requirement for any state, pretty much to open. And I mean, it to me, it's a big deal. And if someone, and again, if the states want to use, if the states want my help in terms of building one of these systems, feel free to reach out to me. This is like, I mean, once you once you follow this presentation, hopefully you'd have an appreciation for how really simple it can actually be. It's never been done before. There's a lot of funding out there, but I have none. Fundamentals. And this is the mind blowing thing about this part, right? About contact tracing. When I started building this program, there are only 2 people involved in contact tracing. There's a person doing the contacting, I call that the person, and the person who is being contacted, right? So I have two, basically in the back end, I have 2 IDs. One is a PID and one is a CID. Contact person being contacted, and the person doing the contacting and the person being contacted. Those are the only 2 people that are involved. All right. But both of them are essentially people. So we'll deal with people and we'll deal with characteristics and classes in C++. We look at AVL tree, binary AVL tree search, and then how to get your program to actually use the binary tree search to to return results. Essentially, I'm building a server, an SQL system using CSV files, right, and classes and all that crap. So it's really, 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 really interesting for me. I don't know about anyone else. And then the grand unveiling, that is, what? How did I get that data to be displayed? All right. How would you organize your data in such a way that you can actually display it? And again, I keep coming back to this thing. You could actually do this in SQL Server or Google, even Google NoSQL, and you could apply the concept, but how do you do it just using memory and input output, right? Processor, memory, input output. All right, and room for improvement. So recall that I said that there are only 2 persons in contact tracing: the person doing the contacting, and the person being contacted. Now we're gonna split everything in rows and columns. If you can split it into rows and columns, you will find that you can make your life a lot easier. Essentially, when you look at your database, you see rows and columns. That's how that's how it's arranged. Now each person, whether if it's the person being contacted or the person doing the contacting, they have characteristics, and these are some basic characteristics that I have in this program. I have the first name, last name. You can have a date of birth. I mean, it's not in the program, but if I were to put it in the program, it'll probably be a struct of integers. I mean, that's all the date really is, right? It's a integer of day, integer of month, and integer of year. Now the addresses, I've separated out the addresses into into a separate class because a person can have more than one address. So um, yeah, a person if you have more than one address, you can actually facilitate that. You could have a person can have 100 addresses if they want. Um, we can facilitate that, and that concept you can actually you can apply it to, let's say you wanted to do location based tracing. So where was this person at this, over within the last couple of days, and so you can use that you can use the class of address to deal with location. So that's an expansion. I mean, as I'm explaining it, that's something that you can actually use your address class to do. Where, so not just the who was contacted, but where. Um, I'm gonna use indexes to link ID to link between classes. A person ID. So each person has an ID, and that ID gets used across classes. So when I'm linking from the person class to the address class, I'm going to use an ID to bridge the two. So I use ID because let's face it, ID, the number is actually easier to start, an integer, versus let's say you have John and then you had Jane, and you have to figure out which one comes first, right? Then you have to go through the J, then you have to go to the next one, then you have to go to the next one. Forget it. You're better off just doing numbers. All right, and I'm coming back to the fundamental. This is the mind-blowing part, and if you can understand this, concept, that there, of all the millions of people in the world, there are really only two people in contact tracing: the person being contacted and the person doing the contacting. And now I see they have pets, so maybe you might even have maybe you can even expand this to build a class of pets, and then you can have a dog as a pet or a cat as a pet, and then you just have all those things as thing, and then link to people. A person has pet A, B, C. I mean, but at the end of the day, it comes back to just two persons in that transaction. That's it. All right. So we looked at multiple data structures in C++, and one of the structures that I'm using here is this binary tree, this AVL tree for search. And the way we learn it in class is that you build this binary tree so that when the user wants data, the user can get the data fast. But how about if you take your program to search its own binary tree, get the result, and then come back, right? That to me is another nice way of using your program. So yes, we talked about traversing, we talked about printing, and that is what I'm saying. The cargo, because each node in your tree, it has in your binary tree, it has a left, it has a right, and there's an int, that number, that person ID that I'm using. Actually, I think what I can do is let me come to the program so you can see the person ID. So here, so a class of person has just these three things. So a person has an ID, a first name, and a last name, like I said in the slide. And that is your cargo. So this int ID, it will use that to separate left or right, and this is your cargo. and then we'll use this later on to pull data and to pull our data into our program and into our other tree. There's another tree that I built that, well, that's actually the grand unveiling. We'll get to that eventually. But for now, it's about the cargo and what you want to do with the cargo. So your program can use the cargo. Your program can use the information that is inside of each node. So like I said, each node, each person node is going to contain left or a right, an ID to determine left or right, and first name, last name. And we will use that cargo. So yes, using the ID and then the cargo to bridge the link. And these are some of my failed approaches. Oh my gosh. I spent about maybe a week trying to figure out, maybe even 2 weeks, trying to figure out exactly, drawing on paper, how this is going to work. How will I get this program to work? My initial thought was a vector, but then I'll have to get a vector for each new person who gets for each new contact, and then you'd have a vector, a vector, a vector, a vector, a vector, a vector. Each it was crazy. And then I thought it was, let me do a linked list, but then I have a linked list of linked lists, and when I thought about it, traversing those lists and vectors, the amount of iterations you'd have to do, it came out to like O of n to the power of n. And there is no way you'd be able, I mean, there's no way that that's feasible. I thought about doing a double binary tree to improve those two ideas. That is, let me store the pointers so that I could find it and then jump straight to that node. But implementing that was a pain. And that brings us to the grand unveiling. The solution. The solution was to have a binary tree and add a third location where it can go. So normally you have a binary tree, you have left or right. But let's put a third part that's called a center. Binary data has 3 tests. You can test whether the number is larger or smaller. You put it to the left or right. Or you can test whether if it's equal. Traditionally, we're taught that if it's equal in a binary tree, you cannot allow duplicates. And that is true for your left and right. But in building this system, and building this contact tracing system, to get that data displayed the way it was displaying on the screen earlier, use a center. If it is equal to, then you go straight down in the center, and you're able to build that. Worst case scenario is that the system runs on O of n, and that's really worst case scenario. Worst case scenario. Best case scenario is that we run on O of log n. Because, I mean, let's face it, it's a binary tree. When you want to search, a million people, you'd be able to get it at, you want to know who this one person got in contact with, and you want to search that system, it'll come out back to log n. So that was pretty good. I mean, this particular solution that, using just these data structures, this solution, it was absolutely, to me, it was absolutely amazing. Like I said, I keep going ahead of myself. I could build it, but building it with C++, it's just really, really good. So room for improvement. Couple of things. Add money. Add more menu. So there are like 2 menus. I'd probably improve on it myself, even if I'm not paid, just because I want the challenge of actually knowing how to things like you can have a menu for doctors, where they enter the test. So if a person gets tested every week or let's say you go move to the point of testing. So you move to the point where people are being tested or test themselves. I mean, the way I see it, right, is I'm sure you'll get to this point, but before you even get to this point, I'm sure because we're in a capitalist society, uh, pharmaceutical companies are going to try are going to want to make as much money as they can, as on thing, and the way they're making that money. I mean, right now it's supply and demand, right? Supply and demand. The supply of the test is limited. The demand for the test is high, and as tests become cheaper to make, that's I mean, the way I see it is, if you can take my person's saliva and then say which location, specific location they're from in the world through their DNA, you can build a home test kit, and maybe that might be a situation where you just test yourself, and then you take the test, and then you enter it into your central database to say that you took the test and this is the result. Excuse me. And so you do that, and then you do the and thing. So one of the menus would be testing. So date of the test, the person who's taking the test, the result, positive or negative. If it's positive, you got to start locating thing. Validation. So validation and the idiot proof basically go hand in hand, because the last thing you need in any system that you're going to roll out that everyone has access to is for there to be some kind of stupid social media challenge where you just flood it with false positives. So a person who has a test, that each test should be validated. That is, each test has a unique number, has some kind of a barcode, and that code gets entered when you do the test. The code can be reused. The code cannot be reused, and that type of validation. But you need something like that in order to garbage in, garbage out. At the end of the day, that's in any system. So you can definitely do that. You can add additional characteristics for people, um, like the data board field. I mean, that's going to be important, because then you want to tell, okay, so then you want to do age and this and that, and then you want to pull the data out of that. You want to pull and analyze the data. So as people are getting, as um, as you are approaching a certain, because you use a data board and then you calculate the age anyways. You don't need a field for age. You can calculate that. But you can then see, I mean, you already know from data collection already certain age group or whatever, medical conditions that a person might have. So those are some of the things that you can build inside. So those are some of the additional characteristics of an individual. Of course, those characteristics, like the you have to separate it out between characteristics that are, and it comes back to characteristics and classes, right? Where characteristics that are, if a person has one characteristic, they have only one date of birth, they have only one first name, one last name. Whether you want to put social security number, that's up to you, but they only have one of those things. All of those things can go into your person class because you only have one. But with address, a person can have more than one address. A person can have more than one medical history. A person can have more than one pets, if you ever go down that road. They can have more than one relatives who live with them, who they might get in contact with. But that's not like even a characteristics. That's the contact. But the I think the medical history you can definitely put something like that in a separate class. Features for doctors to enter test results. Yep, definitely they can enter, or they can be part of that validation process. If it is a mobile app, if you ever decide to build a mobile app, I mean, I'm sure this is what it's going to come down to. If a person tests positive, they can then have a feature that they pull up their contact list and they send a code to say, here's a code, view my profile, this is the location that I've been to, and I have it. So if you know we came in contact within the last couple of weeks, you might want to, you might want to self quarantine, or at least get a test or whatever, just whatever the process is that you need to do after that. But at the end of the day, right, this entire thing is really, it's just, it's pretty, building this program after building this program, to me it's simple. There are only two people. Every single thing else that you put into the system, every single thing else is just an added feature. But the fundamental is that there are only two people. And that's what this program does. So, and that's what I guess any of the programs are going to do. And then everything else, like I said, is just simple features. So, I mean, I don't know. Hopefully, if anyone ever comes across this video and then they look at it and then they're like, well, that makes sense, or that does not make sense, or something along that line, sure. Um, but to me, it's very simple. I mean, it's sad to know that there's, and this is the thing. I mean, I'm doing this for York, for whatchamacallit, and they, I was watching TV, and this is just me venting. This doesn't really have anything to do with the codes or anything. And Bloomberg is on TV, and he says, they're putting together this army. I'm someone who wants to take part in something like this, but then there seems to be some kind of a broken link. To use our data structure terminology, Bloomberg as a pointer, he's pointing to a memory reference that has been deleted, because he's pointing to something. Then my college, York, we don't have, we don't have the information that to say, okay, here's how you can help, here's something that you can do, or here's some, you want to participate. You don't have that. So he's pointing. He says he's working with CUNY and SUNY, but at the end of the day, I mean, this is how I'm getting my information out there. That this is some of the things that we can do, but we'll see how it goes. I mean, hopefully they're able to build a really good program, and I'm sure, like I said, to me it's very simple to build, but we'll leave it to that. All right, I hope this concept for a contact tracing, you're able, it's really meant for software people, computer science people, who this particular video, I mean, like I said, you might not have an appreciation for some of the things that I talk about, because I don't know if you might not understand the terminology. So this is really meant for computer science people. But hopefully you can appreciate the concept and you can understand as a computer science person how you can break stuff down, break a large problem into a very small solution, and a solution that actually works. All right. Hope this helps, and thanks for watching.